Buildings aren't supposed to move. That's kind of the whole point. You build them, they stay there. Decade after decade, storms come and go. Cities change around them. But the building itself stays exactly where it was placed. At least that's how architecture has worked for thousands of years. Now imagine looking out your window one morning and realizing your entire building has changed position. Not because it was rebuilt, not because it was relocated, but because it physically rotated while you were sleeping. And somehow, engineers are actually making this possible. The concept is known as dynamic architecture. Instead of remaining fixed, parts of the structure can slowly rotate throughout the day. Some designs allow individual floors to move independently. Others rotate entire sections of the building around a central core. And the visual effect is absolutely wild. Imagine a skyscraper that never looks exactly the same twice. One day the balconies face one direction. A few hours later they're facing another. The entire skyline changes without a single brick being added. At first it sounds like a gimmick, a flashy idea designed to grab attention. But there are practical reasons engineers became interested in moving buildings. One of the biggest is sunlight. Traditional skyscrapers receive different amounts of sunlight throughout the day. Some areas overheat, others stay shaded. Energy systems work harder to compensate, but a rotating structure can continuously adjust its position, maximizing natural light, reducing heat buildup, improving energy efficiency, and potentially lowering operating costs. Which means the movement isn't just for appearance, it's part of the building's functionality. And honestly, that's where things start getting interesting. Because once engineers figured out buildings could move, they started asking what else could change. Could views be optimized automatically? Could solar panels constantly track the sun? Could entire sections adapt to weather conditions? Could architecture become responsive instead of static? Suddenly, buildings stop feeling like objects and start feeling like machines. The engineering challenge behind all of this is enormous. You're not rotating a small platform, you're moving thousands of tons of steel, glass, concrete, and infrastructure. Safely, reliably, day after day, without people inside even noticing. That means elevators, plumbing, electrical systems, communications networks, and structural supports all have to work together while movement is taking place. And somehow, engineers have found ways to make it happen. Some concepts use massive central support systems. Others rely on advanced bearings and rotational mechanisms designed to handle incredible loads. Everything has to be precise, because when you're moving an entire building, small mistakes become very large problems. And that's why videos of rotating architecture spread so quickly online. Your brain knows buildings aren't supposed to move, so when one slowly turns against a city skyline, it creates an immediate sense of confusion. It almost looks like CGI, especially when viewed from a distance. But projects like these reveal something important about the future of architecture. For centuries, buildings have been passive. They simply existed. Future structures may be different. They may react, adapt, optimize, and physically change based on conditions around them. Which means tomorrow's skyscrapers might behave less like buildings and more like giant machines people live inside. And honestly, that future might already be starting.